Hello class, this is Mr. Goodman, and this is the first formal lesson of Unit 4 Trigonometric Ratios. And I guess the first lesson, 4.1, is uninspiringly titled Trigonometric Ratios. So here we go. This lesson is going to be a review again. In fact, this whole unit really is one big review, so it's going to be sometimes challenging for me to know what speed to go at, but I will try my best. Okay, so right off the bat, we're going to be dealing today with right-angled triangles only. What happens when you have a missing piece of information in a right-angled triangle? And we're going to solve for that missing piece. Now, if you had two known sides, you would use the Pythagorean theorem. But in our case, we're going to be talking about known sides and known angles. And that combination together doesn't allow you to use the Pythagorean theorem. First thing we're going to need to do is be able to actually label your sides correctly. So for angle A, that's this angle right here, I want you to pretend that you're standing in a triangular room. There you are. Now, the three walls of the room have names. The wall that's opposite where you're standing is the opposite wall. The wall that's next to where you're standing is the adjacent wall. Adjacent means next to. Now this wall is next to you as well, but it has the proper name, opposite the right angle, of the hypotenuse. Over here, this looks like the exact same triangle. The difference is that here it's saying for angle B. So in this case, now you're standing in this corner of the same room. However, the walls now have different names because your perspective has changed. In this case, this is now the opposite wall, this is the adjacent, they switched. That is still the hypotenuse. Okay. If we were to write down all the possibilities or the combinations of these walls, then that would bring us to this point here. Now, sine is by definition opposite over hypotenuse. We take the opposite side, divide by the hypotenuse side, and for this particular case it's just A and C because there's the A, there's the C. I wouldn't worry about that too much. Here's cosine, here's tan. Now that says sine A, capital A, that's from angle A we're looking at, versus over here sine B, that's from angle B we're looking at this. Now, how do you remember that sine is opposite divided by hypotenuse, cosine is adjacent divided by hypotenuse, and opposite divided by adjacent here? Well, we got a little rhyme called SOH CAH TOA. You've definitely heard it before, and you have to have that memorized. Now, you could write out SOH CAH TOA like this, but I highly recommend you write it out like this, because it actually orients the information in such a way that you can work with it as an equation. So within the lesson itself, I have this sheet that's partially filled in, and I'm not going to assign for homework or anything. Like, just give it a look-see. If you can do it, great. This is just practice with naming the sides. So I'll do one of them for you so you get what I mean by this. So this is sine B. That means I'm looking for this angle. That means from this perspective, this is the hypotenuse, this is the opposite, and this is the adjacent. Now it says sine B. Sine is O divided by H. That's O divided by H. So that's square root 3 divided by 2. There it is right there. Get what I mean? You do the same thing for cosine, tan, and so on and so forth. I want to point out that this triangle is the same as this triangle, except in these questions it was asking for sine A, here is B, B, B. So it makes a difference. I'll do one more. Cosine B, cosine is adjacent divided by hypotenuse. It's adjacent divided by hypotenuse, that's 1 over 2. Get what I mean? So that's just a little bit of practice being able to label the sides. Hopefully you can do that no problem. And if you can do that no problem, then you're kind of ready to start solving for missing information. So if we were to solve this or state what the trigonomic ratio is for everything angle A, first off, I'd label my three sides: adjacent, opposite, and hypotenuse. And at this point, I have to know that sine is O divided by H. That's 12 over 15 based on this information. We can simplify that fraction. And in fact, we can then turn it into a decimal. And this decimal is what is the trigonometric ratio. This ratio right here is basically saying the opposite side is 80% the size of the hypotenuse. That's basically what that's saying. Here's the same thing done for cosine. There's the trigonometric ratio. And here's the same thing for tan. Fun fact, sine and cosine are always going to be less than 1, but tan can be greater than 1. Just so you know, we can put this in a calculator. So we can actually say, for example, let me make sure that fits. Sorry, just make sure on the screen it fits. Yeah, it fits nicely. So in this here, we have sine 40, and we can just put that in a calculator. Very, very, very important piece. Whenever you have a calculator and you're using trigonometric ratios, or I'm going to say trig ratios from this point forward, you need it to be in degree mode. That little DEG on my calculator is degree mode. Every calculator will have something like that, like a little D or something like that. And if you have something else like an R or a G and you don't know how to get rid of it, most calculators have a little reset button. You can kind of just click right there, and then it resets everything, and the automatic reset is degree mode. So that's something that you absolutely have to do. You'll get different answers otherwise. Sine 40 is a trig ratio. This is this. Those are the same things. We can either write it like this or we can write it like this. So that's about it. We can do that for these other ones. Cosine 50, that's what it is. I'm going to recommend, very unusual here, but I'm going to recommend that you round to 3 or even 4 decimal places. I know that sounds crazy. Usually you're never doing that, but when it comes to trig ratios, you need about 4 decimal places, 3 or 4, to play it safe. And answers you get throughout this unit are going to vary slightly because of that little rounding that has to happen. When you put in cosine 50, you have to make a decision where you're going to round that. And so everyone's going to get slightly different answers based on how they've rounded these things. 4 decimal places is pretty safe. We can reverse this process. And I can say to you, gee, I wonder if this is a trig ratio, what's the number of degrees? I wonder why I crossed that out. I don't know. I actually wrote some of this in a previous lesson. So what we're going to do is to reverse the process. I'll show it to you here. Is if I said up here, sine, cos, tan, above it is a little reciprocal, or sine -1, cos -1, tan -1. Call it the reciprocal. Second function sine, decimal 6, 4, 2, 8. What do you think it's going to give me? Pretty close to 40 degrees, right? We went backwards. So that's just how we reverse the process. So if I gave you cosine A equals this decimal, I'm really saying how many degrees is angle A? So second function cos, decimal 6, 7, 8, 9. It's 47.2. How many decimal places do you round to on this? I don't know. 1 decimal place is usually pretty safe. Okay, so that's what you need to be able to do, something that you have learned before. Let's actually apply it now. So in this case, in this question right here, we're being asked to find an unknown length. So first thing we want to do is we want to use a known piece of information. In this case, we're going to look from this angle. We could have looked from this angle, but I'm going to look from this one because it's given. And now I'm going to label my 3 sides. Opposite, adjacent, hypotenuse. I want the O. I want that information, and I'm looking for the A. Which of these 3 deal with an O and an A? Well, that's an O and an H, and that's an A and an H. Ah, that's an O and an A. I got to use tan. That's how you figure that out, that you need to use tan. You don't really have to write this piece out, but I'm just doing that to show you what's happening. Okay, I'm going to fill in my O. My O is, it's a P in this case, so there it is. And my A is 25.9, there it is. And at this point, it's pretty easy. This is a number, so it's over an invisible 1. I can just cross multiply. P times 1 is P, and 25.9 times tan 47. Now we can actually do that write in the calculator. We don't have to change that to the trig ratio that it is. I can just put tan 47 with my calculator, and that's the answer. Some calculators are funny. You might have a backwards or dyslexic calculator in the sense that you have to put in the 47 first and then the tan. I hate those calculators. I think it makes it a lot harder. So if you have that, good luck to you. Try to find a better calculator. Also, your iPhone has some ability to do this stuff, but you really should be using a hard button calculator. I guess I say that because I'm old school. Maybe you can find some website or something that does it for you just the same. Okay, this one here, here's the angle. Here's what we don't know, here's what we have. Sorry, this is what we're looking for, this is what we have. That's an O and an H. O and an H is sine. So there we go, I'm going to use sine. This one right here, I'll do this one from scratch. I'm looking for this, I have this. This is an H, I can see that right away, and this is an A. So, I have an A and an H. What am I going to look? What am I going to use? Cosine M, because that's angle M, A over H, and I can just fill it in. It's not an M. That's 52. It's actually a known piece of information. That A is 115, and that H is an N. I'm going to cross multiply this, and what that actually will create is kind of this situation, where it's N times cos 52 equals 115, because that's over a 1. So at this point here, N is going to equal 115 divided by cos 52. And there you go. I'm going to call that 186.8. Okay. We can reverse this process if we so choose, right here. I might be running out of time, so I'm going to speed up. I don't know what this angle is, but I want to know what it is. Well, I've got these two pieces of information. That's an O and an H, so I'm using sine. 8 over 17 is that trig ratio. So as a result, what I'm going to do is second function sine decimal 471. And that's how I get my degrees. One more time. D is my unknown. I've got an O and an A, so that's tan. I fill in my information, second function